Hello everybody, welcome back to my channel. Today let's solve a hard question. So that is the largest color value in a directed graph. So description is too long, so I will just use this example one to illustrate. So here there are 5 nodes here, one from 0 to 4, and for each node it has a color. For example, the node number 4, the color of node number 4 is red, and this one is blue, and this one is 2. So the question requires us to count like along a path. So for example, for this path, what is the highest or the maximum frequency of the color? So for this path it has a red of 3 and the blue nodes of 1, so we have to return the frequency of highest frequency, so that is 3. How do we solve this problem efficiently? Traverse the graph, right? And at the same time, if we want to visit the node just one time, we have to keep the median results of each node, so we don't have to calculate it again. For example, if now we have another node and we will link to the node 3. So if we start from the node 2 and we visit this node, and then after visiting the node 2, we want to start from this node 5 and then visit the 3 again. In this way, I don't want to recalculate the result of this path. So I need to find a way to somehow store some the median results on this node. So when I visit the node again, I can just some value from the cache. Keep these two in mind. So what do you think we should use to solve this problem? So it's like a topological sort and plus the memoization, right? Let's start from node 0. So when the node 0, we will go from 0 to 2 to 5 to 6, and we reach the end of this path. So from the 6, we can start to calculate the frequency of the color. So for 6, we have a red, and that is 1 for the 6 only. And now let's backtrack to the 5. So for the 5, we have green 1, and also we need to add back the 6, the result of the 6. So we have a red 1. And then we are left to backtrack to 2. And for the node 2, actually it has 2 paths, so one from this way, the other from the 5. So in order to track the frequency of the colors starting from the node 2, we have to finish both node 4 and node 5. So let's go start from the node 4, and then we find out, okay, 4 points to node 6, but somehow in the cache or in the memory already have that in the 6 there is the result is we have a one red node start from node 6. So we can get it and then store here. So from this node we have a red 1, and we have a blue that is also the 1. And then back to 2. So for back to 2, we have a 4, we have 2 paths. So we like to take the maximum frequency of each color. We have a red 1 and red 1. Okay, so for this node, we have a red 1. And we have a blue 1, and there is no blue, but we want to take the maximum, so we keep track. Okay, there is a blue 1. And then here is a green 1. I also have to plus itself, so the green is actually is 2. And for the node 0, it will just add this one and plus itself. So the, the 0 is a red node, so we will increase the 1 to 2. So after finish this node, we know that the maximum value will be 2. It may be like in red color or green color. Okay. So after finish node 0, we want to go to find next one is from node 1. So from node 1, there are two paths. One is go to 3 and the other go to 2. So let's visit 3. So since 3 is not being visited, so we have to calculate its frequency. So it has a blue 1. Then back to 1. But 1, since 1 is another path, outgoing edge, so we need to visit the 2. And for the 2, we found out, okay, so here is the result of 2, right? And then we back to 1 and find out the maximum frequency. So it's a red one. Okay, so here we have a red one and a blue one and a green 2, and then I need to add back itself, so it is blue 2 actually. Okay, so start from the node 1. We can the highest frequency is still 2, so it's 2. And then after that we are go to visit 2, but we find out the 2 is actually been visited before, so we don't have to count it. And then we find out all of the nodes in the graph has been visited, so the result is 2. You might wonder why we want to keep track of the maximum frequency of all the colors instead of the highest frequency of each one color. Okay, so for example, if now I have a node, a red node, then it points to a green node, then it points to a red node. So start from this node, we will have a red 2 and green 1. But when we backtrack to its previous node, maybe there are red and red. So yeah, we can just use the red and plus this one and plus this one. But there may be some possibilities that these two nodes are green, right? So in this way, we need to keep track of this green so we can know how many green nodes there in the past. So that is why we want to keep track of the highest frequency of each color instead of the highest frequency of only one color. The problem now is we know that we use topological sort, and so what format we can store these values? Okay, so let's think about. So for each node, it will have its color set. It means from the node I, we will have to have a color set is memorize all the colors frequency starting from this node. So it seems like it's a two-dimensional array with the row of this node. So for example, here we have node 0, node 1, node 2, node 3. And then for the column, it is the color. So for example, we have a blue color, we have a green color, we have a red color. So for each cell, it means that start from node 0, the maximum frequency of green node is this number, the value of this. cell. So we want to keep a visited set. So we don't have to recalculate a node again if the node already exists in the visited set. If it already is in the visited set, and then we can just get the value from this 2D array. So now let's start from 0, and 0 all the way go down to 6. So for 6, we have a red one. So we put it here, and then we backtrack to 5. And then in the 5, the first we need to add the next node. So that is node 6. So we want to put 1 here. And then we need to add itself. So the node 5 is green. So the green will put green here. And then go back to 2. But before we want to calculate the 2, we have to visit this path from 2 to 4 to 6. Okay, so since 6, okay, so actually I forget to update the set. So now we have the 6 is already visited. So we have finished the 2D array. So we finish it, and we already finished the 5. And right, so for 4, first, for the 4, we want to visit node 6. And then we found that 6 is already in the visited set. So we can just get the value from the 2D array. So we'll put 1 here, and then we need to add itself. So for the 4, you have a blue one node that is in itself. Okay, so in finish node 4, we would like to put 4 here, and go back to 2. So for the 2, it has 2 paths. One is 4, and the other one is go to 5. For each color, we want to guess the maximum of this one, of these two. So since 1 and 1 equals, so we can put 1 here, and then here is a 1, here is a 0, so we put 1 here. Here's 1, 0, here is 1, so we put 1 here, and then we add the color of himself. So for the 2, it's green one, so we updated from 1 to 2. Then we finish 2, so we put the 2 here. Then we go back to 0. So for the 0, it's just 2. So we can just take the row from the 2. So here we have 1, 1, 2. But the 0 itself is red, so we need to update this one from 1 to 2. And then finish 0, so we want to put 0 here. Next one is 1. So for 1, it has 2 paths. One go to visit 3, another go to visit 2. So let's start from 3. So 3, since 3 is not in visited, so we have to calculate it. So for itself, it has a blue one. Okay, and then put 3 in the visited set. And so back to 1, it has 2 paths, so it has to consider. It needs to consider path 3 and path 2. So we'll take the maximum of these 2 rows. So for this column is 1 and 0, so we put 1 here. So this 1 and 1, the maximum is 1. This is 2 and 0, I put 2 here. The node itself, it is blue, so I change it to 2. Okay, so in the end, I can go through the matrix again and find out the biggest number here is 2. So that is the answer. So now let's start coding. So in this question, I will use these 2 concepts. The first is I will use the topological sort to traverse the graph. And the second is I will use a 2D array, and the 2D array is to cache the frequency of the colors starting from the current node and to the end of the path. Now let's create our graph. So in the graph, I will use a default dictionary. Every element in this dictionary is a list. So for the A and B in each, I'll append the B to a list. So it means that for the node A, it will have all the neighbors in the graph A list. So it will be easy for us to traverse all the neighbors of node A. And then after that, we will also like to initialize this 2D array. So for the 2D array, I will call it as cache. So the row number of the array is the size of the nodes, and the size of the nodes is the length of the colors string. So and for each row, we will have a column. In the column is from the description of the question, it says that given the colors where the colors I is a lowercase English letter, so there are at most 26 colors there of each node. So we like to initialize the current column as a 0, 40, 60, 26 columns. I like to have a visited set. It means I already can visit the set before. So whenever I encounter the set that is already exists in the visited set, then I know I don't have to call the DFS search function again. I can just guess the value I want from the cache. So you can save us lots of time. So now let's start for the DFS search function. So for the DFS search function, I will pass one variable is the node, and another is the path. I want to pass the path because in the description it says like if there is any cycles in the graph, it wants us to return the negative one. So I will have a path variable to to detect if there are any node that is previously visited. If that is true, then there is a cycle in the graph. So we will return -1. But for the DFS search function, I will return a boolean. So if I return the boolean, if I return true, it means there is no cycle. But if there is a false, it means there is a cycle. So now let's start from the best case. So the best case is in the path. Yeah, I just return false. And then if it is not in the path, the first thing is to add a node to the path. And then we want to visit the neighbors of this current node and call the default search function on the neighbors. And before that, we also like to check if I already visit the neighbor before. If that is true, I don't have to call the default search function on that neighbor. So that's in the visited sets. Then I will call the default search function. After I have the frequency of colors of my neighbors, then I can calculate so how many colors are there if it starts from the current node. So here I want to start from iterate of each column, so I will have the column 26 colors, right? And for this 26 color, I just want to get the most. If there is the same color in different neighbors, then I want to guess the highest frequency of the color and put that frequency in the current node on this neighbor. After I put my following neighbors the frequency, and then I need to add myself. It's the current node and the current color. So in the current color, it lies in the color string. So we will have the colors string, but the string will give us a character, but we want to transform it to some index, so we will use the old function to transform the from character to number. Okay, so here if the colors of the current node is also a small a, then the ORDA minus ORDA will return a 0. But if the color of the current node is B, and the order of B minus order of A will return 1. So in this case, we can use the order function to transform from character to the index of the array. Okay, so now we have finished the current node, so we want to remove the node from the path. And besides that, I can mark the current node as visited. And then I can return true. Actually, here I forget to for every neighbor I also have to check if there is any cycle. So if there are any cycle, then I will return false. And after finish the default search function, I can now call the default search function starting from each node. So for the in first, I want to check if the n is already visited. I only call the visit. I only call default search function on unvisited node. So I want to check the called the DFS function. So it's DFS function, and starting from each node, I will give it a new set. It's its path variable. So if it returns a false, it means there is a cycle. So I can just return a -1. However, if it is not, it is true, then I would like to keep a variable. Actually, let's call it frequency. High is the maximum frequency, and initialize it as 0. So the question asks us to return the maximum frequency of the color. So for this one, for each node, we will have a row of colors, and then we can count their frequency by using the maximum function. And then after we get the maximum frequency of that row or that node, then we can compare it with the current maximum frequency, and then update the maximum frequency. In the end, we can return this frequency. Okay, now let's check. Okay, here's some bug. Zero for here I mix in range 26 for in range. There's the colors. Okay. Oh, okay. Can you just submit? Let's check. Okay, it passed. Okay, thank you for your watching.